The next operation we're going to take a look at is powers of I. So first we're going to evaluate some different powers of I. The first one is I squared. And remember, I is the square root of -1. And the square root and the square are inverse operations, so they cancel each other out. So I squared is -1. I cubed can be rewritten as I squared times I. We just showed that I squared is -1. -1 times I is -I. I to the fourth can be rewritten as I squared times I squared. I squared is -1. -1 times -1 is +1. I to the fifth can be rewritten as I to the fourth times I. I to the fourth is 1, so I to the fifth is just I. Hopefully we're noticing a pattern at this point. I to the sixth is I to the fourth times I squared. I to the fourth is 1, and I squared is -1, so I to the sixth is -1. Real quickly, we'll finish up the last two. I to the seventh is I to the fourth times I cubed. I to the fourth is 1, I cubed is -I. And I to the eighth is I to the fourth times I to the fourth, which is 1 times 1, or 1. So what happens is every fourth power of I, you get 1. So to evaluate something on part B, like I to the 27th, you basically need to divide the power by 4 and figure out the remainder. As long as you have I squared, I cubed, and I to the fourth memorized, that remainder will give you your simplified answer. So as I mentioned, we're going to take 27 and divide by 4, which gives us 6 with a remainder of 3. The remainder is our new power, or our simplified power. So I to the 27th equals I cubed, which is -I. So that would be the simplified form of that one. And the last thing we're going to do is take a look at multiplying complex numbers. We had to learn how to work with powers of I before we could multiply, because when we multiply I by I, we're going to get I squared. So similar to working with algebraic expressions, we're just going to use distributive property. So I have 4I times 2, which is 8I. 4I times 2I is 8I squared. But I squared is -1. And when we write our complex numbers, we write them with the real part first and the imaginary part second. So I'm going to flip this around to put it in standard form, and I'm going to get -8 plus 8I. All right, part B, this time we're going to have to distribute twice, so we get 2 times -5, which gives us a -10. 2 times -3I, I times -5, and I times -3I. Simplifying by combining like terms, and simplifying the I squared expression, we get -10 minus 11I, and this is -3 times -1, because I squared is -1. So that's really +3, adding that to my 10, I get a -7 minus 11I. And one last example. Remember what it means to square something. Multiply it by itself. So I'm going to write the 2 plus I times the square root of 3 times itself. Now note that I times the square root of 3 is one term, so I'm only distributing twice. 2 times 2 gives me 4. 2 times I times the square root of 3 gives me 2I squared of 3. And then I have the same thing sitting here. And finally, I times the square root of 3 times itself gives us I squared times 3, because those square roots will cancel each other out when you do the square root of 3 times the square root of 3. So my last term here, remember, I squared is -1, so this is -3. Combining that with my first term, I get 1 plus 4I times the square root of 3 when I combine my like terms.